Hello friends, today we are going to see a fundamental law of fluid statics, that is Pascal's law. Let us first see what is the statement of Pascal's law. Pascal's law states that the intensity of pressure in a static fluid at a point is same in all directions. Now before diving into the derivation, let us understand what is the statement. First we will consider a static fluid. As the fluid is contained in a container, it is not flowing, so it is a static fluid. And we have considered a point in a static fluid where the pressure intensity is acting in x, y and z, that is all the mutually perpendicular axes. Now Pascal's law states that in a static fluid the intensity of pressure at a point is same in all direction. So let us first understand what we need to prove. We need to prove that pressure intensity from x, y and z direction should be same. So that we need to prove today. To derive Pascal's law, we will consider a wedge shaped element of unity width. One unit. Let us name this wedge shaped element as P, Q, R, where the angle Q is theta. Now there are two forces acting on this wedge shaped element. First is pressure force in all the direction, that is x, y and z. You can see the pressure acting in x direction is px, pressure acting in y direction is py, and pressure acting in z direction is pz. Now pressure px is acting on face pq having area dy, py is acting on face pr having area dx, and pz is acting on qr having area ds. Now let us see first part, that is pressure force. Let us consider pressure force acting on face pq. We know that pressure is given as force upon the area on which pressure is acting, and hence the pressure force will become intensity of pressure into area on which it is acting. Now the pressure force acting on face PQ will be pressure intensity on PQ, pressure intensity on PQ, which is Px, into area of face PQ, which is dy, into unity width, that is 1. So we will write it as Px dy. Similarly, pressure force acting on face PR will be intensity of pressure on face PR, which is nothing but Py, into its area. Area is nothing but dx into unity width, dx into unity width. So which will be Py dx, right? Similarly, pressure force acting on face QR will be pressure intensity on QR, which is nothing but Pz, into area of face QR, which is ds, into its width, that is unity, ds into 1. So total pressure force acting on face QR will be Pz into ds. So till now we have seen total pressure forces acting on this wedge shaped element. Now let us move to second part, that is self weight of the element. Self weight is given as volume into rho g. Volume is area into width into rho g. Now area, you can see this is wedge shape element, so area will be area of triangle, half into base is dx and height is dy, width is unity into rho g. So self weight of the element is dx dy into rho g by 2. So we have seen pressure forces as well as self weight of the element. Now you can see the pressure Pz is acting on face QR, which is making some angle with the horizontal. That angle is nothing but theta. So we will resolve Pz into two components. Pz cos theta and Pz sin theta. Now again consider this wedge shape element PQR. In this we can write for cos theta is PQ upon QR. But what is PQ? PQ is nothing but dy and QR is nothing but ds. So I can write dy is ds cos theta Similarly, for sin theta, I can write PR upon QR. But what is PR? PR is nothing but dx and QR is nothing but ds. So I can write dx is ds sin theta. Now let us resolve all the forces horizontally. So first force is Px into dy, which is acting in positive x direction. Second force is Pz cos theta, which is acting in negative x direction. Pz cos theta acting on area ds is equal to 0. Now let us simplify this equation. What is cos theta? From here we can see cos theta is dy by ds. So let us substitute px dy minus pz. For cos theta I will substitute dy by ds into ds. So I get the equation px dy minus pz dy is equal to 0. So I can write px dy is equal to pz dy, right? Dy gets cancelled. I get px is equal to pz. That means intensity of pressure in x direction is equal to intensity of pressure in z direction. I'll name this as equation 1. Now let us resolve all the forces vertically. Sigma Fy is equal to 0. So first force acting vertically upward in positive y direction is Py into area dx. Py dx. Second force acting vertically downward is Pz sine theta into area ds, and again the self weight of the element, which is always acting in vertically downward direction, so it is half into dx into dy into rho g is equal to 0. But as this weight shape element is very small, we can neglect the weight of the element. So the equation becomes Py dx minus Pz sine theta into ds. Again, we can replace for sine theta from here. We know sine theta is equal to dx upon ds. It becomes Py dx minus Pz dx upon ds into ds is equal to 0. So I get the equation Py dx minus Pz dx is equal to 0. Further I can write Py dx is equal to Pz dx, dx is cancelled. I get Py is equal to Pz. Let us make this as equation 2. This means intensity of pressure in y direction is same as intensity of pressure in z direction, right? So from equation 1 and 2 we can write Px is equal to Py is equal to Pz, right? That means in a static fluid the intensity of pressure at a point is same in all the direction. That is the statement of Pascal's law, and hence we have proved the Pascal's law.